Bismillahirrahmanirrahim. It's me, Miss Faradiba from Peshawar Model School, NSR branch. Today I will discuss the forward and backward reaction, which is of my lecture number 3 from class 10 chemistry, chapter number 9, chemical equilibrium. But before going to discuss our topic, I would like you to subscribe our YouTube channel so you will watch our videos continuously. Okay. Let's come to our topic, forward reaction, which can be defined as the conversion of reactant into products per unit time, or the rate of chemical reaction taking place in forward direction is known as forward reaction. As we explained earlier in our previous topics, on that any reaction in which the reactant react and form product, which will be called the forward reaction, or we can say that rate of chemical reaction taking place in forward direction is called the forward reaction. Let's see the common example of water. Let's suppose this is the water in the liquid phase. If we give heat to this water, it will start evaporate and it will convert into gaseous form, or we can say it will evaporate in the vapor form. So this will be the forward reaction, because the rate of reaction proceed in the forward direction. Okay, let's come to the backward reaction. It can be defined as the conversion of products back into reactants, or the rate of chemical reaction taking place in reverse direction is called as the backward reaction. As we explained in our previous topics, that any reversible reaction will be the combination of both forward and backward reaction, or we can say that a reaction in which there is forward and backward reaction occurring simultaneously will be called the reversible reaction. So in any reversible reaction, there must be the forward reaction, or there must be the backward reaction too. So in backward reaction, this product will reconvert into this reactant, so this will be converted back and will give us this reactant again. So in this definition, the conversion of products back into reactants, or the rate of chemical reaction taking place in reverse direction, is called as the backward reaction. Let's see this example. This is the water in the gaseous form, which we get in the forward reaction. So in backward reaction, there will be condensation take place and will give us the water in the liquid phase, or we can write this reaction in this form, when this product which we get in this reaction, forward reaction, this the gaseous form water, or we can say the vapors. These vapors will condense back and will give us the water in the liquid form. So this will be the backward reaction. And if we write this reaction in this in the combined form, so this will be the reversible reaction. Okay, there is some the macroscopic characteristic of forward and backward reaction. So let's see to this topic, or we can say that we will differentiate these forward and backward reaction according to these simple definitions or simple sentences. So first one is, it is a reaction in which reactants react to form product. Simple as that. Whenever two reactants react, there will be any product formed. For example, this nitrogen gas react with this hydrogen gas, it will give us the ammonia gas. So this will be the forward reaction, because the rate of reaction proceeding in the forward direction. Okay, on the other side, backward reaction, it is a reaction in which the products react to form reactants. we can write this reaction in both of these forms. When this ammonia gas reconvert into nitrogen gas and hydrogen gas, so this will be the backward reaction. Or we can write this reaction like this. This ammonia gas react back and will give us these two gases, which are our real, or we can say the first reactants. Okay, the second one is it takes place from left to right, means that two reactants, when two reactants reacting together, it will give us the product. So this will shift from the left to right. So we can represent this arrow as the in the reversible reaction we can represent this as the half-headed arrow, or simply we can represent this like this arrow, but the arrowhead will be from left to right. Okay, in the backward reaction it takes place from right to left. So look at this. In the backward reaction it will proceed from the right to left. So we will represent this in the reversible reaction, and we can also represent this as this arrow, and it will be from right to left. Okay, the next one is at initial stage the rate of forward reaction is very fast. What does it mean by this? At initial state the rate of forward reaction will be fast because there are the more reactants at the start, so the rate of reaction, or we can say the rate of forward reaction will be much more than the rate of backward reaction at the starting time, or we can say at the beginning, because there are too much reactants as compared to product. Okay, let's see at the backward reaction. In the beginning of the backward reaction the rate of reverse reaction is negligible. What does it mean by this? At the beginning and the start the rate of reverse reaction is negligible. Negligible means like nothing, or we can say as compared to the forward reaction, or rate of forward reaction there will be less amount of product, or we can say the rate of reverse reaction will be less than the rate of forward reaction. What does it mean by this? If we look at this reaction, so at the beginning the product will be in less amount as compared to the reactant, but after some time when reaction goes to completion, so there must be there must be sufficient amount of product, and at that time this product will reconvert into the reactant, or we can say that point is the chemical equilibrium, or we can say the dynamic equilibrium. Okay, let's look at the last point. It slows down gradually. Gradually means um, gradually means time to time. After some time it will slow down, or we can say the rate of forward reaction will be slowed down after some time, because the amount of reactant will be lesser in a lesser in quantity, because reaction going to be completion. Okay, look at the backward reaction. It speeds up gradually. Why this speed up gradually? Because look at this. Because when there is two reactants and it goes to and the reaction goes to completion, so there will be the product in much amount, or we can say in sufficient amount. So when this product goes back to a reactant, so it means that the rate of backward reaction will be much more than the rate of forward reaction. So it means that it speeds up gradually. Gradually means time to time it will speeds up, or we can say the rate of backward reaction will be high. Okay. um, Now look at our book. There is the example 9.1. Write the forward and reverse reaction for the following reversible reaction. Okay. So what is the name of this reactant? What is the name of this reactant? Its name is the nitric oxide. When nitric oxide reacts with the oxygen gas, it will convert into nitrogen dioxide gas. This is the reversible reaction, and we are going to write their forward and backward reactions, or we can say the forward and reverse reaction. Okay, this is the solution. This is the nitric oxide, and when forward reaction, when this nitric oxide react with the oxygen gas, it will convert into nitrogen gas. And according to these steps, or we can say these points, at the starting time, their rate of forward reaction will be higher and the rate of backward reaction will be lower. It takes from left to right. It is a reaction in which reactant react to form products. At initial state, the rate of forward reaction is very fast. In initial state, reactants, the quantity of reactants will be higher, so the rate of forward reaction will be faster. It slows down gradually. Why it slows down gradually? Because time to time the amount of reactant will be lesser in quantity, and the amount of product will be higher. So the at the end it slows down gradually. This is the reverse reaction. When this nitrogen dioxide convert back into these reactants, it will give us the nitric oxide and oxygen gas. So according to these steps, it is a reaction in which products react to form reactants. It is a reaction in which the product react to form reactants. It takes place from left to right. So we can write this in the opposite form. Like this. But here the nitric oxide has been written at this side. Okay, in the beginning the rate of reverse reaction is negligible. At the beginning the rate of reverse reaction will be negligible, means lesser as compared to the forward reaction. Why? Because at the start the amount of product will be lesser than the amount of reactants. But after some time it speed up gradually. Why it speed up gradually? Because after the completion of reaction, the amount of this product will be higher than the reactant, so it means that the reverse reaction will be uh, speed up gradually means time to time. Okay, now this is the practice problem number 9.1. Write the forward and reverse reaction for the following reversible reaction. First one reaction is the when carbon react with water in the vapor phase, it will give us the carbon monoxide and hydrogen gas. What is a forward reaction? At the forward reaction, when carbon gas react with the water in the vapor phase, or we can say at the gaseous form, it will give us the carbon monoxide and the hydrogen gas. Its backward reaction is when carbon monoxide and hydrogen gas react back, it will give us the water in the gaseous form, and also the carbon in the gaseous form. The reaction number 2 is when hydrochloric acid react with the oxygen, it will give us 2 moles of water and 2 moles of chlorine gas. This is the reversible reaction. So how we can write the forward and backward reaction for this reversible reaction? In the forward reaction, when hydrochloric acid react with the oxygen, it will give us the 2 moles of water and 2 moles of chlorine gas. And in backward reaction, these products react back and will give us the 4 moles of hydrochloric acid and also the oxygen gas. So this was all about the forward and backward reaction, and I hope you will completely understand this topic. Okay, thank you so much, students.